Without the lathe, man would not have been able to develop modern industries, nor would he be able to make the many machines and mechanical parts upon which all industry depends. From the lowly but important bolt to more complicated machine parts, the lathe, oldest and most important of all machine tools, stands behind the machines which help bring us a livelihood. From the powerful diesel locomotives that pull cracked streamlined trains on the railroads of our country, to the office typewriter or the living room radio, the lathe plays its part in our daily lives. Wherever there are precision parts or precision machines which make the commonplace things we use, there also is the lathe. Steamboats and ships ply our rivers and lakes, cross the oceans of the world safely and swiftly, because somewhere a lathe has accurately made the mechanical parts which furnish their power. Many of the things which we identify with modern life, whether it is the spectacular airliner carrying passengers, mail and express, or the dusty tractor plowing the farmer's field, were developed and are made by the lathe. Mass production, like that of our automobile factories, has been made possible by lathes. They and the manufacturing machines made on them have, through mass production, made available to millions of people at a cost they can afford the conveniences of modern life. Under the hoods of automobiles, buses, and trucks, gasoline engines do their daily jobs with parts made on the lathe. Everywhere about us are the products of this machine, the only machine which can reproduce itself. Unsung mover of our mechanized world, the lathe is a precision machine tool. The back-geared screw-cutting lathe is designed to hold and rotate work of many kinds and materials while it is formed to size and shape with a cutting tool. To meet the demands of modern industry, lathes are accurate and durable. They have ample power for the type of work for which they are intended. Ease of operation is obtained by convenient arrangement of the controls. Of equal importance with the lathe in providing many of the necessities and comforts of our lives is the machinist who operates the lathe. His skillful coordination of hand and mind enables him to perform precision lathe operations with ease. Because of the great variety of work to be done, lathes are built in different sizes, but regardless of size, make, or type, their operation is basically the same. Today, as always, industry needs skilled machinists. Let us take advantage of this opportunity to learn what we can about the care and operation of a lathe. The young man with loose, dangling sleeves and flowing tie has no place in the shop. Ties should be removed and sleeves should be rolled up. The lathe has 4 basic parts. There is the bed, which is the foundation upon which the lathe is built. The 3 inverted V's and the flat surface are called the bedways. They are used to align the important units of the lathe with extreme accuracy. The headstock is mounted on the left end of the lathe bed. The headstock transmits the power which rotates the work, the metal or other material which will be formed to size and shape by machining in the lathe. At the other end, the right end of the bed and sliding on the bedways, is the tailstock. The tailstock serves as a support for the right end of the work, or it may be used for mounting tools. The carriage is also mounted and travels on the bedways. It has an apron equipped with various controls, a saddle which spans the bedways, a compound rest, and a tool post. The tool post is used to clamp the cutting tool to the top of the compound rest. It is designed to hold the tool securely when cutting various kinds of metal. Perfect alignment of the headstock, tailstock, and carriage is maintained by the V-ways of the lathe bed. The precision of this alignment is of great importance to the production of accurate work. Power for rotating the work is transmitted to the headstock by a leather belt running over its cone pulley. Let's watch this operator and see how the lathe works. When work is to be machined between centers, it is placed on the headstock spindle center and driven by the faceplate through a lathe dog attached to the work. The tailstock is fixed on the bedways by tightening the clamp bolt nut. The hand wheel is turned to adjust the tailstock center to the work. Before starting the lathe, the operator must arrange it for the correct spindle speed, which is determined by the diameter and kind of material to be machined. This lathe has a 4-step cone pulley, which, with the back gears, provides 8 spindle speeds, 4 direct belt drive and 4 back-geared drive. The lathe is now operating with the back gears engaged. They provide the slower speeds. For high spindle speeds, the back gears are disengaged and power is transmitted by direct belt drive to the spindle. To arrange the lathe for direct belt drive, the back gear lever is pushed as far to the rear of the lathe as it will go. The bull gear lock pin is pulled out and then up. The cone pulley is revolved slowly by hand until the bull gear lock slides into place, fixing the cone pulley to the spindle. Small diameters like this can be machined efficiently at the high spindle speeds, which are furnished by direct belt drive. These high spindle speeds are also used when fine feeds are employed for taking light finishing cuts on work in the lathe. To set up the lathe for back-geared drive, the cone pulley must be disengaged from the spindle. The bull gear lock pin is pulled out and pushed down. The back gear lever is then pulled forward. The cone pulley is revolved by hand to make sure that the back gears have been engaged. The back gear should never be engaged while the spindle is revolving. For machining a large diameter like this, or for taking heavy cuts, the slower spindle speeds, which are provided by the back gears, must be used. The compound rest is adjustable for various types of operations. By turning its ball crank, the tool may be moved toward or away from the work, or it may be given an angular movement for taper turning, bevel turning, or boring. Spanning the carriage is the cross-slide of the saddle. The cross-slide ball crank enables the operator to move the compound rest and the cutting tool by hand. This controls the depth of the cut and the size to which the work is machined with micrometer accuracy. For facing operations where a flange or the end of a shaft is to be machined square and smooth, the cross feed may be operated by power instead of by hand. The tools that are used for different operations in the lathe are shaped differently. The tool for this facing operation, for example, is not the same as that used in the turning operation we saw when the operator was reducing the diameter of the work. Various tools are used for different operations in the lathe. With the apron hand wheel, the operator can move the carriage along the length of the lathe bed by hand. The carriage is moved in this manner for bringing the tool into position and for starting a cut. Usually, when taking a longitudinal cut, the carriage is moved along the bedways by power. For turning operations like this, the bedways serve to keep the carriage correctly aligned so that the tool moves parallel to the center axis of the work and thus produces a true cylindrical shape. The feed change lever controls automatic power longitudinal feeds and the automatic power cross feeds. When it is in the center or neutral position, all power feeds are disengaged. When placed in the upper position, the gears in the apron are engaged for automatic power longitudinal feeds. When the feed change lever is placed in the lower position, the gears are arranged for automatic power cross-feed. The automatic power feed clutch is used to engage or disengage either automatic power longitudinal feed or automatic power cross-feed, depending upon the position of the feed change lever. On this demonstration apron may be seen the mechanism which, by hand or by power, moves the carriage along the bedways through a pinion and rack beneath the upper front part of the bed. When the automatic power feed clutch is engaged for power longitudinal feed, the carriage is moved along the lathe through a system of gears which drive the pinion. These gears are actuated by a worm gear and a spline or keyway in the lead screw. The threads of the lead screw are not used for automatic power feeds. This is the feed reverse lever. When placed in the center position, it disconnects all power to the carriage. When placed in either the upper or lower position, power is transmitted to the carriage for automatic power longitudinal or cross feeds. The direction of automatic power longitudinal and cross feeds is reversed by shifting the feed reverse lever from the upper position to the lower position. The split nut lever is the other control on the apron. It is used only when screw threads are to be cut on work in the lathe. The split nut, which is controlled by this lever, is threaded to fit the lead screw. Here on the demonstration apron, we can look behind this lever and see how the split nut operates when threads are cut in the lathe. As the split nut lever on the apron is moved, the split nut is closed and its threads are engaged with the threads of the lead screw. The split nut can be engaged only when the feed change lever on the apron is placed in the neutral position. When a thread is cut on a job in the lathe, the carriage is moved along the lathe bed by the thread of the lead screw. A gear system at the headstock end of the lathe connects the headstock spindle with the lead screw, and that determines the pitch or number of threads per inch that are cut on the work. The quick change gearbox is a transmission for changing the ratio of rotation between the headstock spindle and the lead screw. By shifting its gears, screw threads ranging from 4 to 224 to the inch may be cut. The gearbox also controls the rate of automatic power longitudinal feed and automatic power cross feed. The small figures are feeds in thousandths of an inch per revolution of the spindle. The large figures are threads per inch. Although the operations that have been demonstrated in this picture have all been performed on one type and size lathe, the basic principles and the manner of operation are the same for all lathes, regardless of their size or type. These operations and methods are used for every type of job which is done in the lathe, whether it's a simple or highly complicated machine part. There are several types of lathes. The lathe which we have used, for example, is an underneath motor-driven lathe. A driving motor is mounted beneath the headstock. It is connected by a belt with the lower cone pulley, which matches the headstock cone pulley. Here is a bench lathe with horizontal drive. The motor for driving this lathe is mounted on the bench at the rear of the lathe's headstock. A bench lathe may also have underneath motor drive. The motor is mounted in the bench beneath the headstock. Cone pulleys, like those in the larger lathe, transmit the power from the motor to the headstock. While the lathe used in this picture and those we have just seen were all equipped with a quick change gear mechanism, this bench lathe is what is known as a standard change gear lathe. In order to cut threads with different pitches or to control the rate of automatic power longitudinal feed and automatic power cross feed, the operator must change the gears at the end of the lathe by hand. But regardless of the type of lathe on which he works, the good operator gives this valuable precision tool of industry the best of care. The lathe should be thoroughly and carefully cleaned after the day's work has been finished. All metal chips which have accumulated should be cleaned off the lathe to ensure the precision surfaces of the bedways from any possibility of damage. Just as important as cleaning off the lathe at the end of the day's work is the first thing that a good operator does every day. Before work is begun, the lathe should be thoroughly oiled. Correct oiling helps to keep the lathe in good condition and to maintain its accurate precision performance of the jobs which it is to do. All parts of the headstock and the quick change gearbox should be oiled daily. Best practice is to oil all parts in a regular sequence. Oiling thus becomes a habit and no parts are missed. The apron and its controls should be oiled. The dovetails of the cross slide and of the compound rest should not be forgotten. The V-ways and flat surface of the bedways should be oiled to keep them in the best condition for their important use in aligning the headstock and tailstock centers and the carriage. Oil should be placed on the bedways beneath the tailstock, and the tailstock itself should be oiled. Before cutting screw threads, oil should be placed on the threads of the lead screw. When the lathe is not in use, all bright parts should be covered with a film of oil to prevent rusting. The lathe is a highly accurate precision tool manufactured to do precision work, and it should be given correct and careful treatment in use. The principles of lathe operation demonstrated in this film will be applied to various types of work in other films of this series.